We're building the world's largest decentralized manufacturing network, and the goal is to democratize manufacturing for everyone. If I told you, hey, you've got 1 minute to start selling this globally today, how are you going to get this made, and how are you going to put up the money? You have to go to what, Shark Tank? Or with $3, you could literally click this, put it on your Instagram, and start selling the merchandise within seconds. The masses will start to unlock business potential. If you look at like what Stripe did, payments, right, made it really easy. Shopify, it made it easy to create a web storefront. And $3, we're trying to make it easy to do manufacturing. All this capacity, idle capacity, billions, it's a $15.6 trillion manufacturing market, and there's just billions and billions of dollars of equipment sitting idle all the time. The way you can think about 3D printing is it's a robot in a box. It's an automation for manufacturing that can do some things. It can't do everything, and there's different 3D printers, there's different plastics, there's different sizes. Basically, a $500 printer can do what a $200,000 printer could do like 10, 20 years ago.
Welcome to Are DePIN, a podcast dedicated to the world of DePIN projects. Every episode, we invite amazing DePIN projects to explain how they're revolutionizing and shaping the future of DePIN and Web3. Our goal is to keep you informed about everything happening in the DePIN space. This podcast is brought to you by Minima, the real-world blockchain. Minima is a device-agnostic and fully decentralized Layer 1 blockchain. It has a lightweight architecture that enables a full node to run on any mobile or IoT device, making it exceptionally adaptable for scaling decentralized physical infrastructure networks. Minima's technology is now supported by an expansive and engaged community of over 50,000 node operators. Join us for the next insightful discussion. Hey, John, how are you doing?
Excellent. How are you?
Yeah, very well, thanks. It's such a pleasure to have you on the podcast because we started this podcast to create a community of DePIN projects. And as everyone knows, DePIN stands for Decentralized Physical Infrastructure Networks. And you and 3DOS specifically, you guys take the physical part of that of the acronym very literally, and that's why I'm really excited to talk to you guys, because you guys are all focused on manufacturing. So yeah, why don't you just quickly introduce what 3DOS is?
Yeah, 3DOS is, we're building the world's largest decentralized manufacturing network. It's a DePIN, and the goal is to democratize manufacturing for everyone. As you know, today it's really difficult to get things made. You most people go to Alibaba, most people go to one country. There's all this capacity around the world. So we believe that DePIN is an amazing way to coordinate all this supply and demand. And we have a decade of experience with 3D printing. We created one of the world's first operating systems for 3D printing, 3D Printer OS. And so the idea came that imagine you could just upload a part one day and start to sell it globally. No taxes, no customs, no tolls. So that's the goal of 3DOS, is democratize manufacturing. And we're excited to move forward on this journey.
So tell me about how the journey started. So because manufacturing has been around for a long time, right? So like, how did the journey start? What problems did you guys observe in the market that you guys thought, a decentralized solution could really remedy this?
Yeah, I mean, for me, it started from a young childhood. I always liked to make things. Both my parents had PhDs, so we built our own computers. And this is back in the day, CP/M, DOS. You had Radio Shack. So I was making a lot of things, and it was always, a large barrier of entry. So I went to the computer science world because you could go to production very quickly. And I always knew that these two worlds would collide. And, I worked at Dell, and at Dell, we did, just-in-time manufacturing, where people order computers online and we would build them at the point of need, time of need, basically. And because, the hard drive costs were changing. So I saw this low latency manufacturing. I saw the automation trends. And then it's about 15 years ago, the desktop 3D printers came out. I'm like, wow, this is exactly what I've been waiting for. Imagine being able to click a button and it makes a form factor. I can get a Raspberry Pi, put it in there, and it can be an IoT clock. It could be a heart pace monitor. You're starting to make it accessible for the masses to make products, iterate, prototype. And so about 15 years ago now, I started creating an operating system, which is called 3D Printer OS. And the idea was I saw these 3D printers, and they're sitting around like cappuccino machines. You have to go use them individually. And I said, this is not the way it should work. So we started to cluster those together with our software. And now 3D Printer OS is the number one 3D printer management software for desktops. It's used by like MIT, Harvard, Yale, Purdue, Duke, and these um, local universities, and and also big companies like Google use our software that they can just upload a part, and inside their intranet they can just immediately get parts made, right? So you're reducing latency between design and manufacturing. You're bringing this close to zero. And the vision was always, okay, well, how do we go one step further? You've got manufacturing, low latency now, but how do you go global distribution? And that's where the three DOS um, vision came into play, and where DePIN was an amazing weapon, I think, to make that accomplished, is that it's a coordination layer, right? You can program those things into the smart contract. I don't have to have a lot of overhead. So that was kind of the trajectory. It started with a problem that I wanted to solve, being able to manufacture low latency that spread into universities, enterprises, even NASA uses it. And now the vision's all right. I've made that once inside my office. How do I globally have that distributed without inventory, without shipping, so on demand? Yep.
Talk me through how practically it works as a platform though. So you as an enterprise would sign up and you would upload a part. Am I missing something? And then what happens next?
Yeah. So it happens like this. So let's say you're an enterprise. Let's say you're even using my previous product, 3D Printer OS. It's in your office. You print it once. You print it twice. You print it 100 times, and you're like, look, guys, we don't need to have this injection molded. We can put this on an inventory system, and then we can use this network called 3DOS. And anytime someone purchases it from our website, 3DOS has this network of 3D printers that are ready to do work. Like this, is like a decentralized printify, if you can imagine. And so that would be the um, you know, kind of like path. And so the idea now is that you've got 3DOS, you have all these decentralized printers. If a person orders in Africa, we find a printer that's compatible with that part in Africa and it gets produced. If that printer is in Austin, Texas, we find a printer in Austin, Texas. If a printer's 5 feet from your house, we find a printer 5 feet from your house. So the proximity and the time to get that and the scale becomes not a problem anymore. You don't need to have a million of these things made or 10 million of these things made, stored in multiple warehousing. Like at Dell, we stored stuff all over, and we had different SLAs, 1 hour, 4 hour, 24 hour, 48 hour for parts. And it was huge cost to keep all those parts, spare parts in FedEx hubs. So that's the goal. Um, you can upload a design, and then if it's purchased, it's made anywhere on demand.
Hmm. That does sound amazing when you think about it, because there's no minimum order quantities anymore for manufacturers. There's none of that. Even experimenting with new products and things like that. There's none of that, and it goes directly to the end user. So yeah, that sounds incredible, and it also it's like it unlocks worldwide distribution sort of from day one.
Exactly. So it doesn't matter if you're an influencer or you're like a company like Bosch. Within seconds, you can sell merchandise or certain types of parts globally.
Hmm. When it came to, I guess, starting this, because it's an amazing idea, and then I get like scaling it. What was the sort of main challenge, I guess, when it came to starting and then growing?
Yeah, so I kind of give you a trajectory of where we are. So we just launched on the SWE mainnet last week. Um, Went from zero to about 10,000 users, and it looks like here my notes, we did about 24,000 3D printed parts, which are NFTs, and so that was since last week. So we just launched. Now, to be fair, I had a lot of users already from my previous product that were ready to try it out. So that was a huge benefit, is to already have a community that is ready to try something new. But yeah, the initial growth was spectacular, and now we're looking to scale that and add in all kinds of advanced machines, all kinds of advanced capabilities, and continue to grow.
Mm. Is that what's the sort of longer term with when it comes to this sort of technology? Like I know this is 3D printing, but I guess how far can this go?
Yeah, I mean, the way you can think about 3D printing is it's a robot in a box. It's an automation for manufacturing that can do some things. It can't do everything, and there's different 3D printers. There's different plastics. There's different sizes. There's different processes. There's liquid polymer. There's metal printing. Basically, um, there's all kinds, and there's even some machines that have 3D printing and CNC. Now, the vision of 3DOS isn't just 3D printing. This is just something that we have in our back pocket, and desktop printers are accessible to a lot of people. But um, really, just like Amazon started with books, we'll start with 3D printing, but then CNC, water jet, all this capacity, idle capacity, billions. It's a $15.6 trillion manufacturing market, and there's just billions and billions of dollars of equipment sitting idle all the time. So the vision is to start with desktop printing, expand to industrial 3D printing, expand to CNC, water jet, and really start to compete with some of these publicly traded companies that do billions of dollars with on-demand manufacturing.
That was my next question. Actually, is that it sounds like it's such a disruptive technology and model to the manufacturing sector. That's is, as you said, multi-trillion-dollar industry. How much can this disrupt that industry?
Yeah, I think the key ingredient with blockchain doing it right in DePIN is low latency and low overhead. So if you look at our competitors, they have thousands of employees. If you look kind of like what USDC, for example, did to the banking industry, um, you have banks, thousands, hundreds of thousands, if not millions of employees around the world in offices. Yeah, checking routing information, wires, but I can just like within seconds send money anywhere in the world through a smart contract, right? So that smart contract sets up rules to govern that transaction, to work on the coordination between the transfer of money. Very similar. That's our goal with 3DOS is we have all our competitors and even startups that are raised $680 million, 1,600 employees. It's a web form. You upload a design, you start chatting with someone, you get on a phone call. But we proved with 3D Printer OS is, I have thousands of um, students at Duke University that can just upload and go straight to the machine and print within seconds. So that's the idea, is to build a smart contract that provides the governing rules for how the routing happens, how the quality scores happen. It's all on chain, right? So I know if a manufacturer is on time to quality, I know exactly who's delivering it, which nodes are high performing, like Bitcoin mining. You can route to high performing nodes. Very similar to like even Uber. If I'm okay with waiting 2 weeks to get a lower price, or like Lyft, if I'm willing to wait 20 minutes to get a lower price, we can route that, and that's all baked into the smart contract. So the coordination layer, um, instead of having thousands of employees, is automated, and it's very precise and it's very honest because everyone can see that on chain, right? Everyone can see everyone's quality scores on chain. So I think that's the power of the low latency automation, self governance of a deepened blockchain project, and that's what we hope to automate to defeat our incumbents, and really make this accessible to the world, right? And it's open source, right? So people can start to develop APIs. So if it's not 3D printing, it's XYZ machines or XYZ types of capacity. They can start to add that capacity. The system figures out who is the best to receive those orders. And vice versa. You can also see who's submitting those orders. Are they reliable? Is the design properly set up for that machine? So pretty amazing. And that's what we want to do. We don't want to be in the middle with thousands of employees um, coordinating transactions. I think that's the old way of doing things.
Mm. And what does your sort of ideal customer profile look like in terms of the sort of customer that would use something like this? Because I imagine it works well for, as you said, the sort of demographic where they don't want to waste time when it comes to minimum order quantities or even, the latency periods, as you said before, but it might not hit the ones that want to go sort of very, very mass products. So I guess like what does the sort of ideal profile look like from your side?
Yeah, I mean it's interesting. There's a pretty good variety. So we have 4 to 5 orders coming in a day, and even before we launched, and I would say about 15-20% with some very serious enterprises like Swatch or I think Blue Origin, and then there was a lot of people that were creating new businesses or just needed one-off parts. I had a guy, actually a few of them, that were making electric vehicles, electric bicycle attachments, GoPro mounts. We have another one that's making toys like dragons online. And he's producing like 20K in revenue. So he wanted a way to connect their printers. And some people didn't have printers and they wanted to print the prototype once. And now they're figuring out, okay, I've printed it once and I want to sell this. There's like an electric charging mount for a bicycle. Um, and so if you go to Etsy now and you type in 3D printed whatever, Stanley Black and Decker attachments, people are starting to create these businesses. And so I think the masses, um, yeah, the masses will start to unlock business potential. I think one of my investors said it best. If you look at like what Stripe did, it extracted payments, right? Made it really easy. If you look at Shopify, it made it easy to create a web storefront. And 3DOS, we're trying to make it easy to do manufacturing, right? So if you combine that, payments, any type of marketplace, and then now you can manufacture, then I think that's kind of the wave of the future, right? Low latency, low overhead, democratized. Anybody, whether it's a teenager or Stanley Black and Decker, can come in, get parts made for them and their customers with no inventory on demand.
And I guess you are creating a new sort of business opportunity in new markets yourselves by introducing this technology because as you said, people can develop things very quickly, they can experiment very quickly with products. So yeah, I completely see that. I guess like from that segment of customers that you talked about, as well as some other ones that you can think of, what are some case studies that you think this is what really makes my heart happy when it comes to building something like this? What have you seen that really excites you?
Yeah, I mean, I think what's really exciting is some of the big stuff. So, for example, we have a client called Arrow Edge. We met at Berkeley Skydeck, which is kind of a premier innovation hub spot. And they want to do, well, they are doing components for the new GE Leap engine. And just to give you an idea what this new GE Leap engine is, it has a lot of 3D printed parts, and their Arrowedge is a Toyota subsidiary from, and they basically have this engine saves 15 to I think 20% fuel, like incredible amounts. And I think GE makes the fuel nozzle 3D printed, so the way it mixes oxygen and air, you can't build that any other way. And then with Arrowedge, they have these turbine blades, and their goal is to manufacture those in Japan, and then have these machines all around um, in 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 airports, so they can build those parts if there's an issue, and then take the data from the machines and have constant improvement, right? So you have basically, instead of one centralized factory with high latency, building a lot of parts, then finding out that they fail, then recalling them back, printing them on demand, making small iterations, having really tight controls, digital controls. I think that kind of stuff is very exciting to see, like really big companies thinking this way. gets me excited. And then, of course, I'm super excited on the other side of the spectrum too. I mean, excited to learn. Like, if you make an iPad stand like this or an iPhone case, right? Like, if I told you, hey, you've got 1 minute to start selling this globally today, how would you do it? There's no other way. Okay, you got 10 minutes, you got an hour, you got a week, you got a month. How are you going to get this made? And how are you going to put up the money to get this made? You have to go to what, Shark Tank and ask, give 50% of your company. Or with $3, you could literally click this tomorrow, put it on your Instagram, and start selling the merchandise within seconds. And if it's the red one that sells, or is it the blue one that sells? You can find all that out within, basically real time, right? So I'm excited for both sides of the spectrum, um, and we'll see. Like, there'll be different demand for different machines, and different machines will attract different types of use cases.
Hmm. That's really interesting. I personally find the exciting part with the smaller side of, smaller businesses can experiment far quicker. They have global distribution very, very quickly. The risk and startup costs are minimized because they can, as you said, like print an iPad stand very, very quickly. And they have to go to a manufacturer and fork out, $1 or $2,000 just because they want to experiment with one product. So that's what really excites me. But it is, as you said, it impacts both sides of the spectrum. Um, I'm interested, John, in terms of where you think this will go, I guess, like in the future, because 3D printers are kind of the bottleneck, I guess, in some regard in terms of innovation of the 3D printers. So in terms of the 3D printing side, where do you see that going?
Yeah. So if you kind of map out a trajectory in 3D printing, so since the patents expired like 20, 30 years ago, the printers are getting cheaper and cheaper and cheaper. The quality is getting better and better and better. And a a, a, basically a $500 printer can do what a $200,000 printer could do like 10, 20 years ago, right? And so now you're seeing people clustering those machines. There's going to be about 2 million machines made a year this year. There's going to be 22 million made by 2030. That's like really tomorrow in 5 years, right? So there's going to be, and the market's going to grow to $105 billion market for just 3D printing. And there's some use cases where people have 1,000 of these desktop printers. So if this is an hour or 2 hours to print, I can make 1,000 of these an hour now. And now you're competing with injection molding, right? Um, so that's very exciting to me. Very similar to what happened to the computer industry. Initially had really large mainframes, very expensive. Only the elite could access them, right? I mean, you had to be NSA, or you had to be um, Oracle or some huge company to get access to these huge computing resources, and still today. And then desktop computers came out, right? GPUs came out. People started clustering these machines. People started Bitcoin mining, right? People started. So I think the similar mega trend will occur with 3D printing. And the 3D printers themselves are getting more advanced in materials. So, desktops really could do something called like PLA, which is like, it was made out of corn. Now they're going into even metal on a desktop. You can use metal filaments, and then you can have it censored. So the material science is also changing. So it's moving pretty quickly, and a lot of these machines are now starting to transition into production. It was almost like 0% of these machines were doing production parts, and then like companies like Carbon 3D, you'll see like these Adidas shoes or Nikes or helmets, or even Selle saddles, which are used for bicyclers. You go to a bicycle store today, you can find the 3D printed Selle, and other brands of biking saddles, right? And the way that there's design is, instead of using one elastomer, they have these lattices, looks like little Eiffel Tower type structures, right? And you can make it more dense in some areas for different types of rebound. And you can also customize it, helmets, lots of stuff. So very excited with the technology. It's the hardware is becoming a commodity. It's becoming more standardized. And so if you have all those machines around the world sitting idle, that's a huge opportunity that we see.
Yeah, as you said, so the 3D printers, they're going down in cost, but they're, tech advancement is increasing. The materials themselves are becoming more advanced and easier to use, I guess, in some regards. But then in terms of the decentralization and Web3 elements, how can that aid the innovation?
I think it comes down to the smart contract. Um, you know, you don't want to be in the middle of that many transactions. That's a huge overhead. You know, if we can program that in such a way that supply and demand and routing is all programmed into the smart contract with quality scores, I think that's going to be a huge, huge shift in how things are done today. I mean, today, like I said, if you want to make this, like, I mean, let me ask you this: where would you start? Like, if you want to make a million of these, where would you go today?
Well, I probably have to design it, so I don't know how to
Okay,
do
let's
any
say
of
you got
the
the
sort of
design.
design. Okay, if
You
I
got
got
the
the
design,
designs,
yeah,
well, I have to go to Alibaba. That's the first place, and try to
right.
find, like, just search for, yeah, injection molders or like
And how
people
much are
that,
you
that
going to
work with
charge you for
plastics.
your first
Well,
order?
yeah, I imagine minimum would be sort of what, like 10,000 units if I'm lucky.
Yeah, luckily, if you're lucky, and then um, let's say it doesn't sell, and you have another idea right after you went to production, and you have another idea. Like, um, it's just it's a completely different way that we never had access to before, right? Like, we never had access to clicking a button in the digital world and it becoming physical. Like manufacturing, like even if you go to like a Thomas Net, which is like Yellow Pages, like you would contact thousands of people, get thousands of quotes back if you want to be really efficient, right? You have people and companies doing that all the time, going to suppliers, bidding against suppliers. So this is like a much more efficient model. I mean, I can say like it's like what USDC is to the banks, 3DOS is to classical manufacturing.
I think that's a brilliant note to end on, honestly. So, John, before I wrap up the podcast, I want to ask you one more question, and I like to ask this to all my guests around DePIN. So, what is your favorite use case of DePIN outside of what you or like immediately do at 3DOS?
Yeah, the first that comes to mind is probably Hive Mapper. Um, um, I think what they're doing is very interesting because you already have people driving around anyway, and you look at the kind of the cost. So, my understanding is Google spent, like $2 billion, and they spend that every few years to have their own cars, their own people mapping around the world. And then you've got a $18.5 million investment where you have got everyone has, kind of equity and a collected goal. They're already driving around anyway, and they're able to collect same, similar, or even if it's not as good, but like you're collecting this mapping data. I think that's pretty amazing. The power of the people versus one centralized company. And I mean, I think there was a quote from Amazon CEO. He even sees his company going extinct someday. I think he said it like 5, 10 years ago that he sees someday that there could be a decentralized version of Amazon. And it's basically the coordination layer, right? You have already all these people that are ready to do work. You have all these idle assets. So I think HiveMapper is uh, pretty inspiring for us, and we use them as a role model. And there's many other ones as well, but that's the one that stands out the most.
I mean, there is some overlap, I guess, from what you guys are doing to say an Amazon, right? Because they sell a lot of products that could be 3D designed and 3D developed, and if you can sort of cut out a platform like Amazon and go direct to the designer or the manufacturer or the developer or whatever it is, or the brand itself, there is a lot of use case for that. and people can get their products for cheaper as well, given that you're cutting out a lot of the supply chain. So Amazon's huge. Like there's many different facets of it, but for one specific part of it, I can see where someone like 3DOS can replace certain elements of it. I don't know what your take is on that.
Yeah, I mean, it's even a few steps further. So before you get products on Amazon, you still need to buy them from Alibaba, right? So if you kind of go through the workflow of someone that's creating an Amazon store today, they usually look at trends and what's selling. They go find the same suppliers of someone else that's selling a competing product from Alibaba. They get inventory. They have to put it. They have to spend money for that inventory in the warehousing, and then they usually kind of break even or they get ahead a little bit. And then what they do is then they go downstream to who actually makes those products, right? With 3DOS, we're cutting out all of that. We're going straight from material, right? 1 kilogram of plastic's like $20, right? Straight to physical form, right? Like it's like even it's at the beginning and the end of it's the beginning of creation and it's the end of like receiving the final product. Like it's just completely compressed. So with 3D printing, it kind of provides this remarkable digital to physical bridge that didn't exist before.
100%. Thank you, John, for coming on the podcast. It was such a pleasure having you on and talking about 3DOS. I'd love to ask you, how can people stay in touch with you and what you're doing going forward? Because I'm sure they will be.
Yeah, you can follow us at our Twitter. It's 3DOS Network. Our website's 3dos.io, and register, and looking forward to democratizing manufacturing for the world.
Fantastic. Thank you so much for coming on the podcast again, John, on We Are DePIN, and I'm sure I'll chat very soon to you. Thank you so much.
Excellent. Have a great day. Thank you.
Thank you for listening to today's discussion, brought to you by Minima, the real-world blockchain. The only Layer 1 blockchain lean and compact enough to run in full on any mobile or IoT device. If you're new to DePIN, subscribe to our YouTube channel and follow us on Twitter to stay up to date. Thank you so much again. We'll catch you in the next episode.